Welcome to the class, my dear students. Now, in today's lecture, I am going to do in the discrete probability distributions. We are now entering into the first variety of the discrete probability distribution, that is the binomial distribution. The name binomial, it's a bi means what? 2. So when the outcomes, the number of outcomes is 2, then it is for you have to do that. You have to understand that it is binomial. So what are the important concepts and when do you use this binomial distribution means? These are the things to understand. It satisfies the following conditions. What are they? There are only two outcomes, namely the success or the failure. So the best examples, many examples you can take, tossing of a coin, you have either head or a tail, or writing the examination, you have only two outcomes, whether it is pass or failure, or shooting the target, either it hits the target or doesn't hit the target, like that. So there are only two possibilities. If the question is, you have written a question where you have true or false, suppose there are only two possibilities, either it is true or it is false. And then if you are watching this video, that means watching of this video is, there are two possibilities, either to watch or not to watch. So these are the binomial, these are the two cases where the two outcomes you have. So whenever you are talking about any only two outcomes are there, then it is binomial distribution, first thing. And there must be a fixed number of trials. That means what? The number of trials must be, so this is that the coin is tossed 2 times, or the coin is tossed 3 times, or the experiment is being done some n number of times. Then we say that it is a fixed number of trials are there in this binomial distribution. Coming to the outcomes of each trial must be independent. What do you mean by this? The outcomes are not depending upon the other. That means when you are tossing a coin, getting of a head is totally independent of getting of a tail. Correct? The outcomes must be independent. And the probability of the success remains the same for each trial. It cannot be different. When you say that getting the probability of getting head is 50% means definitely it is 50% for all the trials. So it will not change. It is the same for the whole practical or whole the experiment. So the probability distribution of the binomial experiment is called as the binomial distribution. So the probability of the n trials is given by this formula. What is that? P of x is equal to r, we can say. P of x is equal to r is given by NCR into P of p to the power of r into q to the power of n minus r. So this is what the formula. NCR times of, I'll write here very clearly, I can write it, otherwise that is best. So the probability distribution for everything, there is a distribution function will be defined. So what is that? P of x is equal to r is given by we were given by NCR times of p to the power of r into q to the power of n minus r. So that is what the probability distribution. So P of x is equal to r is given by NCR into p to the power of r into q to the power of n minus r. This is what the formula. What is p here? The success. Q is 1 minus p, that is the failure. Or we can say 1 minus q. Q is equal to 1 minus p. This is what the probability, that is what the success means. Okay. So you have to remember this formula to do what are all the problems are depending upon this. Why this is the formula now? You are selecting the number of the trials, or the fixed number of trials is n here. How many times the experiment is happened is n here. And what are the favorable events, that is the number of events of getting heads 2 times or something like that, it is r, and p is the success and q is the failure. When the success, when you take the number of times the favorable event, which is p to the power of r, then when you say that it is not a success, that means 1 minus p, that is q, that can be done in how many ways? If this happened r times, the failure happens n minus r times, right? That is q to the power of n minus r. This is what the formula you can understand. And what is the mean of the binomial distribution? It is n into p. N means what? The number of trials. P means what? The success, the probability of success. And variance is given by n into p into q. So this is what the problems you will be having. Try to understand now. I'll just ask you about some of the questions here. For example, I write that p of x is equal to r, b of x is equal to 2, let us say, and let me write that n is equal to 5, and write down what is p. P is equal to, let us say, 0.3. Then what is p of x is equal to 2? According to the formula, it is NCR into p to the power of r into q to the power of n minus r. Okay, this is what the probability distribution. Now, as I told you, your r is now it is 2. Understood? R is equal to 2. So, how will you write this? P of x is equal to, actually you can write the formula like this. P of x is equal to r is given by this. Now, when I say that r is 2, P of x is equal to 2, then how will you write this? 5c2 times of 0.3 to the power of 2. And what is q here? Q is what? When p is 0.3, q is 1 minus p, that is 1 minus 0.3, and that gives you 0.7. So this is what? 0.7 to the power of n minus r, that means 5 minus 2. So you can do this calculation, whatever, 5c2 times of 0.3 to the power of square times of 0.7 to the power of 5c2 times of 0.3 the whole square times of 0.7 the whole cube. Okay, like this you have to do. I am not going to do the calculation part. I just wanted you to explain you what is P here and what is Q here and what is the success and how to find out the failure. Or if the failure is given, suppose if Q is given, you have to find out P. What is that? Now from this, can you find out the mean of this binomial distribution? The mean is given by n into p. What is n here? 5. What is p here? 0.3. So 5 into 0.3. So it is 1.5. That calculations apart. Now I am doing just the how to find out these values when question is given. So mean is equal to np into q. What is n here? 5. What is p? 0.3. What is q? 0.7. I hope you could understand. What is the standard deviation? It is the square root of the variance. So whatever you get here, that is the square root. I hope you could understand. So first you have to remember this formula. NCR, P put to the power of R, Q to the power of N minus R. That you must memorize. Then see what is N and see what is the success P and what is Q, 1 minus P. And then what is R? R is what? P of x is equal to the R is 2. So P of x is 2 is this much, 5c2 times of 0.3 the whole square times of 0.7 the whole power 5 minus 2. So that gives you the solution. Once you get the probability distribution, even without doing this also, because you know all these values, you can find out what is mean and what is variance and what is the standard deviation. I hope you could understand how to solve the problems. Now let us come to the next problem now. So coming to the problem, it is the identical computers are shipped in such a way. Identical computers are shipped in boxes of 5. About 15% of components have defects. Boxes are tested in a random order. So what is the probability that a randomly selected box has only non-defective components? So what was asked, that is the success. What was asked in the question, that is what the success, or that is what your favorable event. Okay, what is favorable event here? That is getting the non-defective components. So, and one more thing, in the examination you will not be in the questions, many questions, you go to any competitive exams also, whether you have to do binomial or whether you have to do Poisson or normal or exponential, nothing will be given to you. You yourself should understand which distribution you are going to do. There it's a challenging task for all of the students actually. Now coming to the problem here. So what is that here? That is the probability that a randomly selected box has only non-defective. So now coming to the problem, you have to understand each and every sentence, each and every word in the question. There are some components and they have defects. So what do you mean by that? Some components have defects means some components doesn't have defects. So there are only two possibilities. When there are two possibilities, it is binomial. This is what the understanding. So what you can say is there are only two possibilities, correct? The two possibilities are What are the two possibilities? Defective and non-defective. So when do you say when there are only two possibilities, therefore you must use the binomial. That is what the understanding. Is that clear? Therefore binomial. Now let us come to the problem. What was given here and what is x here? Our favorable event is what? Let us have that as non-defective. So our favorable event is non-defective. So let us now say what is that given? 15% of the components have defects. So when I say have defects, what is this 15%? Means it is 0.15, correct? Can we say what is P or Q? Now I will clearly tell you, please understand one thing. What was asked is non-defective. That means whatever it was asked is your success. Success is P. Now given that this that means P is the probability of non-defective items. But what was here, this 15% is having defects. So the failure is 15%. I hope you could understand now. So what you can say about this 15% now is Q, because they have defects. Q is 0.15. So what will be P now? It is 1 minus Q, that is 1 minus 0.15 and that is 0.85. So you know now what is P and what is Q. And now what is N here? Totally how many boxes? That means the identical computers are shipped in the boxes. X is equal to 5. And what is the probability that a randomly selected box has only non-defective components? So that means the non-defective components totally is equal to 5. That means whatever x is equal to 5, totally n is also equal to 5. We need to see that all the boxes, whatever you have, that should be non-defective. So to show that it is non-defective, my favorable event is what? Whatever you select the box, that should be non-defective. So how much is the probability is the question. So it is 5C5. Your R is also 5, N is also 5. And then, okay, let me write down the formula first. P of x is equal to, P of x is equal to R is what? NCR, P to the power of R, Q to the power of N minus R. Now here, all the boxes should be with non-defective. What is that probability? So what is probability of x is equal to 5? That means 5C5. Probability of the success is 0.85 to the power of 5. Failure is 0.15 to the power of 5 minus 5. It is equal to 0. Okay. So what is this? 5C5 is 1.85 power 5. You do this, that is 0.4437. So this is the answer of, that means what it is, what you can understand from the problem, the probability that the randomly selected box has only non-defective components. That means to get that it is non-defective, so the probability is how much it is given by totally it is 44%. So what do you mean by this? Therefore, there is 44% probability of getting the non-defective item or box, or the non-defective box. Probability of getting non-defective box is 44%. I hope it is clear to all of you. So this is what the way to understand the problem and do it by using the binomial distribution. Let us now have another question. The overall percentage of failure is 20. If 6 candidates appear in an examination, what is the probability that at least 5 pass in the examination? So in the question what was asked is 5 pass in the examination. So the X is passing, and even the success is also pass. I hope you could understand. What was asked? Suppose if the question it was asked that what is the probability that at least 5 fail in the examination, or at most 5 fail in the examination, then what is that? Means fail is your success. Okay, what was asked in the question, please, I am stressing the point that don't say that success means always pass, failure means fail in the examination, or D4, or whether in the previous problem we have taken the defective item, so the defective item itself is success. No, not like that. Whatever was asked in the question is your P. Clear? I think so. So let us now go to here. Again, there is a percentage of failure and pass. So there are only 2 possibilities. So it is binomial. It is understood, right? So now, what is X here? X is what? Pass. That means P is pass. The success is pass. So now what was given? The overall percentage of failure is 20. So what is Q given? 20%. 20% means 0.2. So this is given. When Q is 20%, what is P? 1 minus Q. That is equal to 1 minus 0.2. That is equal to 0.8. And there are how many candidates it is given? 6. Therefore, you know the number of trials which is fixed, which is equal to 6. So you know N is equal to 6. And you know what is P. You know what is Q. And at least 5 pass in the examination. So the question asked was, at least, I have told you in the beginning of my probability class itself that whenever it is asked at least means you should understand it is greater than or equal to. Okay, so P of X greater than or equal to 5 you need, suppose. What is the formula? That is nothing but when I wanted that X is greater than or equal to 6, greater than or equal to 5 means how many probabilities I need to calculate? Either X is 5 or X is equal to 6, correct? So P of X is 5 plus P of X is equal to 6. Now what is the formula for P of X equal to 5? It is NCR. Your R is 5 now, so N is 6 now. So 6C5. Now what is P? P is 0.8 to the power of 5. What is Q? 0.2 to the power of 6 minus 5, which is 1 plus. P of X is equal to 6. I hope you could understand what I am doing here. This P of X equal to 5 is this value, correct? This is the value. P of X equal to 5 is this value. And P of X equal to 6 is now what I am going to do. So let us now write down this. What is P of X equal to 6 means? XC is 6, 0.8 power 6, 0.2 power 6 minus 6, which is equal to 0. I hope it's more clear now how to use the binomial distribution. Is that clear? So let us now do the calculation. What it is? 6C5 into 0.8 power 5 into 0.2 power 1. All these you can use your calculators. Calculators are allowed in the examination. So the value is 65536 is the answer. I hope it is clear, all of you. So this is what the way of construction of the binomial distribution already has given you. What to find out in the question is what you have to understand properly. I hope I am clear.